All right, let's go ahead and talk about section 9.10, and here we're going to go ahead and talk about the inverse trig functions. Okay, so we're going to go talk about sine, cosine, and tangent today. The first one is just asking us to go ahead and graph sine of x if we're going from a negative 2 pi to a 4 pi. So I'm going to go ahead and start just by labeling my graph. And I'm just going to go by pi's all the way to 4 pi, right? We're going to go 1, negative 1 on my y-axis. And we know that this is how my sine function goes, okay? And again, it's talking about, okay, is y equal to sine of x a one-to-one function? One-to-one function, right, that just means that for every x value, there is one y value, okay? And to check to see if it's a one-to-one function is using our horizontal line test. So that in this case is, okay, if I were to draw a horizontal line, right, I should only get 1 point of intersection on my function. Here looks like we have 1, 2, 3, 4, 5, 6. Okay, so this would not be a one-to-one function, so I'm going to go and say no. It's inverse, right? Just the inverse of it, so the flipped version of it. Would that be a one-to-one function? No, right? Okay, so we have to go ahead and this is kind of the stuff that we did before. It's asking us to go and find the solutions to the equation sine of x is equal to 1/2. Okay, and we know that in sine, it's positive, so there should be two values of x. We have pi over 6 plus 2 pi k, and then we also have 5 pi over 6 plus 2 pi k, where k is in the set of my integers, right? That's just what we did. Okay, so then if it is not a one-to-one function, then we have to go ahead and restrict our sine function. So I'm going to go ahead and look at my picture up here. Now I'm going to go ahead and literally take a little piece of it that would make it a one-to-one function. So I'm going to go ahead and erase that guy. And I'm going to go ahead and highlight that section right there. Okay, so this section right here shows me that yes, it is a one-to-one function. That means that my horizontal line test will go ahead and pass. So then I'm going to go ahead and take this guy and make it as my restricted sine function. So it looks like if I was going back to like my sine function, that's pi over 2, negative pi over 2, and here's pi over 2. Okay, so I'm going to start with negative pi over 2, 0, pi over 2. We're still going up to 1 and negative 1. So my first point is at negative pi over 2, comma negative 1, 0, comma 0, pi over 2, comma 1. And if I'm looking at the curvature of this graph, right, we're going to be looking like this. Okay. Now again, my domain for this one looks like it is from negative pi over 2 to pi over 2. And then my range is going from a negative 1 to 1. Okay. Now I'm going to go ahead and list my points up here. So like I said, we have negative pi over 2, comma negative 1. We have 0, comma 0, then pi over 2, comma 1. And the inverse is we're literally going to take these values, our x and y values, and go ahead and flip them. So I'm just going to switch them. So now we're going to start with negative 1, comma negative pi over 2. 0, comma 0 stays the same, and then 1, comma pi over 2. So my x values for my inverse sine function is going to go from negative 1 to 1. And then my y values is a positive pi over 2 down to a negative pi over 2. Okay, 0, comma 0 still stays the same. Negative 1 goes down to a negative pi over 2. 1 goes to a pi over 2. Now it is an inverse, so my function, like the curvature, does flip. So instead of starting out down this way, I'm going to go ahead and go up first and then decrease all the way up to that point of 1, comma pi over 2. Okay. Now my domain, then it switches from a negative 1 to 1 And then we have my range of a negative pi over 2 to pi over 2. Okay, so if I'm looking at my restricted sine function and my inverse sine function, right, the one that we really want to go ahead and pay attention to is the domain of the restricted sine function. This is going to help us determine, okay, what quadrant are my answers going to be lying in. So if I'm looking at, and I could chat about this a little bit further, but if I'm looking at my like unit circle, right, here's pi over 2, here's a negative pi over 2, right? We're going to be looking at our functions in quadrants 1 and in quadrant 4. Okay, so keep that in mind when we're going to go ahead and evaluate some of the stuff below. But pretty much you see that, okay, if my domain of my restricted sine function is negative pi over 2 to pi over 2, then my range is going to be a negative pi over 2 comma pi over 2 for my inverse sine function. And same exact thing with my range of my restricted sine function, the domain is going to be that same exact interval of negative 1 to comma 1. Okay. Now the next part is saying solve each equation using the restricted sine function. So here again we're talking about the domain of a negative pi over 2 comma pi over 2. So we are looking in only quadrants 1 and 4. It is the same exact thing with like our basic trig equations, right? You're going to ask yourself, okay, what x value gives me a sine of 1/2? Right, and I know you want to say pi over 3. It is the opposite. It's going to be pi over 6. Okay, same exact thing for the second one. What x value gives me a sine of 1? Gives me pi over 2, and it checks out because pi over 2 is included in my domain. And then you're thinking, okay, what x value gives me a sine of a negative radical 2 over 2? Now here, right, sine is negative, so we're thinking about in quadrant 4. It's okay to think of terms of like 7 pi over 4, but I want to make sure that we're staying in the domain. So 7 pi over 4 is not my domain. So I have to think about it in terms of our like reference angles. Okay, so another way to say this one would be a negative pi over 4. Okay, and then I have, okay, what x value gives me a sine of 0? This is just going to be 0. Okay. And we do have new notation. So here when we're talking about the inverse value of sine, you might see this one that you've seen like on your calculator or whatever, but you're also going to see sine of x. And this time what you're going to ask yourself is the angle whose sine is blah, blah. Okay. So we're going to go ahead and solve each equation using the inverse sine function. So this is where I made my mistake. You're going to go ahead and fix this real quick. We are not evaluating x, we're actually going to be evaluating y. So go ahead and erase that, cross it out, do whatever you need to do, white out it, and we're going to go ahead and evaluate y. Okay, so again you're thinking, okay, what angle measurement gives me a sine of 1/2? And you're like, oh, okay, sine of 1/2, that's going to give me a pi over 6. So I'm going to have pi over 6. Same exact thing for the second value. What angle measurement gives me a sine of 1? I'm going to say, okay, pi over 2. And then what angle measurement gives me a sine of negative radical 2 over 2? This gives me negative pi over 4. And very similarly, this one's going to give you 0. Okay, now you might be thinking, oh wait, the domain of my restricted sine function is from a negative 1 to comma 1. But here the domain is your x values, right? You're looking at your y values. So here is strictly your y values, and the domain of my y values is from a negative pi over 2 to a positive pi over 2, which again is in quadrants 1 and in quadrants 4 for my sine function. Okay, so it's very similarly with cosine of x. If I were to go ahead and graph this one out, here's negative 2 pi, pi, 0, and so forth. I'm still going to go up to 1 and -1. And there is my cosine function. Looks something like that. Okay, so again, cosine of x, this is not a one-to-one function, so I'm going to go ahead and say no. So then the inverse is not going to be a function. Okay, now it's asking us to go and find the solutions to the equation. Cosine of x is equal to 1/2. This is when x is equal to a pi over 3 plus 2 pi k, and then a 5 pi over 3. Yep, plus 2 pi k. Again, where k is in the set of my integers. Okay, so same exact process where I have to go ahead and restrict my cosine function. This one I'm going to go ahead and start at 0, and we're going to end at pi. Okay, so we're still going to go up to +1, -1. Here's my 0 mark, here's my pi. My first point is at 0, 1. My second mark is at this point right here. This is really pi over 2. And then my third point is at pi, -1. And this is my function. It has a little bit of a curvature. Okay, the domain does change. It's from 0 to pi. A little bit different from our sine function, but my range is still the same, going to -1 to 1. Okay, so my points that I was looking at, I was at 0, 1. I'm at pi over 2, 0, and then I'm at pi, -1. The inverse, I'm just going to go ahead and flip these guys right here. So we're going to have 1, 0, 0, pi over 2, and then -1, pi. So here's -1, here's pi over 2, and 0. So -1, pi, that's my first point right there. 0, pi over 2 is right there. And then I have 1, 0. And now this is my inverse function of cosine. Okay, where my domain is now at -1, 1. And then my range is at 0 to pi. So same exact thing, right? We're just going to go ahead and flip the switch from the restricted cosine function to my inverse cosine function. Okay, but again, for the first part, when we're solving each equation using my restricted cosine function, we're only focusing on the domain of 0 to pi. So if I were to go ahead and draw my unit circle, right here, 0, here's pi, we're only focusing on quadrant 1 and then quadrant 2. So here again, quadrant 1 and then quadrant 2. Okay, so this stuff is just the basic ones. So you're asking yourself, what values of x give me a cosine of 1/2? And you're going to say 1/3, or sorry, pi over 3. Same exact thing. What value of x gives me a cosine of 1? This is just 0. And then you're asking, okay, what values of x give me a cosine of a negative radical 2 over 2? That's going to be in my quadrant 2. And this one, it's going to be 3 pi over 4. Now that is in my domain, right? 3 pi over 4 is less than pi, so we're fine. And then you're asking yourself, what values of x gives me a cosine of 0? And this is going to be my pi over 2. Okay.